Everyone, we'll be starting with the session now. Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 5G. Myself, Anshika Jain, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th February 2024, and the virtual event is being held through Zoom yesterday and today, that is 21st and 22nd February 2024. I hope you will enjoy the knowledgeable and informative sessions throughout the day. So, coming to the guidelines, in this session, we will have 6 presentations, and each presenter will be given 12 minutes for the presentation and 2 minutes for the questions and answers. And it is my request to all the participants to kindly stay connected with us till the closing remarks. If you have any query or any updates, you can write it to me in the chat box below. Just before we get started, I would also like to introduce you to our session chair, Dr. Preeti Parwekar. Ma'am is an associate professor in the Department of Computer Science and Engineering, Faculty of Engineering and Technology. She has been an academician from the past 20 years. She holds a life membership of IEEE, ACM, CSI. Her research interests include Internet of Things, cloud computing, machine learning, wireless sensor networks, software engineering, information retrieval systems, social media, and data mining. Welcome to the session, ma'am. Would you like to share a quick opening remarks with us?
Thank you so much, Anshita. I hope I am audible.
Yes, ma'am, you are audible to us.
Yeah, thank you for the introduction. And I welcome all the authors to this session and wish you all the best as the instruction as given by Anshita. So we'll stick to the time. And I'm eager to listen to all the new research authors. Thank you.
Okay. So we'll be starting with the presentations now. So first up, we have Hussein to present his paper titled Emotion Detection Through Facial Expressions for Determining Students' Concentration Level in E-Learning Platform. So, are you there?
Yes, good afternoon.
Good afternoon, sir. You may start with your presentation now.
Hello, good afternoon again. Sorry, I'm having a flu from for the last 2 days, so my voice might not be clear. So my research title is.
Sir, have you presented the screen?
Sorry, say again.
Have you presented the screen? We shared
Yes.
your. We can't see it.
Sorry. Actually, I normally use Microsoft Teams. Yeah. Is it visible now?
Yes, yes. You may start your presentation.
Okay, all right, okay. Hey, good afternoon again. So let me start. My research title was Emotion Detection Through Facial Expression for Determining Student Concentration Levels in E-Learning Platforms. So I'm a student at University Kuala Lumpur in Malaysia. So just all right. So this is the quick overview of my research, of our research. So in this paper, we're basically addressing the challenges students face during learning platforms And then there's a lack of interactions in e-learning platforms. And then facial expression, we are basically analyzing a student facial expressions to determine student concentration levels. So lastly, we develop a prototype for determining student concentration levels in e-learning platforms. So this is basically a overview of e-learnings platforms where there's users, there's a student, there's a teachers, there's administrators. So since we are focusing on a student's emotional state, so just to give a quick overview of what is emotions. So basically, emotions is a mental state both on neurophysiological changes variously associated with someone's thoughts, feelings, and then behavioral response. So the emotion can be categorized to basic emotions, which are happy, sad, surprise, fear, and then compound emotion, which are combination of basic emotions. So the emotion can be recognized using someone facial expressions or body languages can be done through vocal tone or verbal communication and physiological response. So in our research, we basically focusing on facial expressions. So after reviewing the existing research, so we are able to find out these problems in existing e-learning. So you find out that firstly there's a loss of personal interactions and proximity between the teachers and students, and there's a difficulty of understanding student feelings and behaviors. There's a difficulty in motivating students since the lecturers or instructors don't know whether a student is focusing or not. And there's a inaccurate emotional assessments since since the instructors unable to estimate the students' concentration level. So there's obviously there's inaccurate emotional assessments, even though sometimes it might be the student is not focusing, so the lecturer thought the student is focusing, student getting what he is being delivered. So there's a research questions, and there are two basic we are able to come out with the two research questions. This is the main two research question, although there are many others. So first research question was, how can facial expression analysis be effectively utilized to detect students' emotional state in e-learning platforms? And the second one, how this contributes to major concentration levels and improving the online learning experience for students. So these are the research objectives. First one is to analyze student facial expressions in an e-learning environment using e-learning platforms. Secondly, to develop a prototype to identify student concentration levels from their facial expression, which will help the instructor or teachers to change their teaching strategy according to the students' need. And lastly, we evaluate our prototypes in order to find the accuracy and how effective is the prototype is. And then, so research contributions. There are three main contributions. Our research is contributing in these three main parts. First is assessment of the students' concentration levels. Focus on, and then second is management of contextual informations, and then it helps to tailoring its content to students. So scopes. There are a few ways, as I mentioned earlier, to recognize students' emotional levels. We are only focusing on facial expressions, and then this research only focusing on 6 basic emotions. Although there are many more, which are happy, sad, surprise, fear, disgust, angry, neutrals. So we are only focusing on 6 basic emotions. These are literature review. After reviewing the many papers, we're able to find the research gaps. So the methodology, and how did you able to find the students' emotional state? As so in the methodology parts, the researcher adapt certain methods. We have gone through many methods that have been used to recognize student emotions. So you have customized it in according to our research needs. So, and these are research methodology. These are basic things involved: data collection, processing, development, training, and evaluating all this. So these are our prototype architectures. Basically, we use a Kaggle FER 2013 dataset, which is a open source dataset, to train our modules. The model has been developed using CNN. So we save our modules and then we use the students and more e-learning based videos. We used around 20 students videos, and then these videos we have classified it using cascade classifiers and then other classifiers, and then we use these videos to feed our created modules, and then from there the model is classified. It has been classified the student emotional state, which are whether students into happy, sad, surprise, fear, disgust, angry, neutrals, and then from there it has measured the concentration score using the gauge weight and emotional state, and then dominant emotions. So from there, if the student is concentrated, it's create a graph actually to visualize the student concentration levels, and then if the student is not concentrated, it's notified the lecturer that the student is not concentrating. So from there, the lecturers can change his teaching strategy. So data collections, the primary data, we use the experimental, we done experiments to collect our data, and then second one, as I mentioned, we use FER dataset. So these are the data pre-processings. It's a model developments. We use, as I mentioned, we use Keras, and then we applied CNNs to design for emotional detections. Data augmentations, it includes we done the data rotations, and then zooming, horizontal flipping, all this has been done. It's a training modules. Here we use CNNs, and then base size use 32, and then we use 100 epochs. We use Adam optimizers, and then loose function use binary cross encrypt tree. So evaluations for performance metrics, we use the trainings, model training process, and performance metrics accuracy and loss are monitorized and visualized using matplotlib. Here is our visualizations of our created the accuracy and then the validations. You can see here the trainings accuracy has claimed up to 70%, and then validation accuracy around 60%. More than that, actually, around 65%. These are model loose. You can see the loose. When it's come to 100 epochs, it has almost 0 point something, so which is considered as. Here is a confusion matrix. You can see our modules. Happy is the. You can see here the happy was our modules. The happy is easily classified, and then we can see the the fear was the hardest one to detect. And these areas here is sorry, it's a precision. Here's so how did you calculate the attention levels, students? Basically measure the attention levels using the emotion and gauge weight emotions. There's a predefined emotions. We have given we have given a predefined weight to each emotions, and then we have multiplied into the gauge weight how much time students is focusing on the lectures. His left eyes blinking actually. So from there we have we have multiplied the emotional state and then the gauge weight in order to find the attention levels. So and then we have if the student's attention levels reach up to 65%, then we consider a student is fully focused. If attention levels less than 45, we say just concentrate. Even the student's attention levels less than
Sorry to
25,
interrupt.
we said he's not concentrating anymore.
Sorry to interrupt, sir, but you have
Yeah,
2 minutes to conclude your presentation.
yeah. So these are the graphs showing the chart. Yeah, I'm about to. These are just a screenshot of our prototypes. So yeah, that's it. Thank you. I'm so sorry.
Thank you so much for your presentation, sir. Ma'am, any questions?
Yeah, Noman Hussain. Good work, Noman.
So sorry.
I have some couple of questions for you. As you said that you have used FER 2013 as a data set. Am I right? Hello?
Yes.
Yeah. So how have you taken the 6 basic expressions? Was it only the passport size photograph? Only the face photograph from the database?
Yes, this is a open source data set actually. I mean,
Okay.
from the Google, so you can see it's a Google data set. So we have downloaded from there, and then we have customized it according to our needs. We have done the pre-processing.
So which method have you used pre-processing?
Sorry. Somewhere.
And how many hidden layers were there for CNN?
Sorry.
How many hidden layers? You have used neural networks? Convolutional neural network, CNN, right?
Neural network is a
Right.
predefined module.
How many hidden layers was used in that one?
It actually a predefined modules. I got it from also from the internet. So I have just customized it.
All right. All right. All the best. We can move on to the next presenter.
Thank you.
On to the next presentation. For next presentation, we have Aya to present a paper titled Leveraging Machine Learning for Identifying Occupancy Patterns from Power Data with a Moving Window Feature Extraction Method. Are you there, ma'am?
Yes, I'm here.
Okay, you may start with the presentation, ma'am.
Okay.
Yes, ma'am, we can see your screen. Yeah.
Okay,
we'll start.
thank you. Okay, good morning. My name is ICICT, and I'll be presenting the paper entitled Leveraging Machine Learning for Identifying Occupancy Patterns from Power Meter Data with Moving Average Feature Extraction Approach or Method. And I'll be presenting the paper on behalf of the other co-authors, which are Dr. Faisal, Dr. Yassin, and Engineer Mahdi. So we'll be starting with an overview of the sections that we'll be covering throughout the presentation, which are first an introductory section about occupancy detection in general and the approach utilized in this study. And then we'll be covering the study methodology, mentioning that the data sets used in the study and the moving time window approach. Following, I'll be discussing the results and compare between the results found with applying the approach and without applying the approach. And finally, the presentation will be wrapped up with some concluding remarks and mentioning the potential future work. So occupancy detection could be based on utilizing many types of data. So some people use camera images, others use mobility data such as Bluetooth, Wi-Fi, or GPS. And some people also use, or some studies use a network of sensors that comprise temperature, humidity, motion, and other environmental sensors. And also some works, they utilize smart meter data. It could be aggregated or appliance level. And as for the output of the occupancy detection system, it could be either binary occupancy status, which is like either 0 or 1, and it could be also occupancy resolution, which is like the head count. It could be like number 1, 2, 3, or 0. And also some people do activity classification, which could be like walking, sitting, running, and etc. So in this study, we'll be focusing on using smart meter data. And since all the data sets that we found, they utilize, they have a binary occupancy status. So this is the output that we'll be having as well. Okay. So you can see like two figures of two examples of our data sets. And you can see like the power consumption data here and also the occupancy label, which is in red. So either 0 and 1. And you can see like there's a correlation between the electricity usage pattern and the occupancy status. And in both homes, this is like home A and this is home B, you can find an association with the occupancy. And if we concentrate on home B, you can see like there is a spike in the electricity consumption when the person is at home. And if he's not at home, you can see like the consumption is low. And however, for the home A, you can notice that the correlation is a bit weaker compared to home B. And you can observe this if you focus on this time instance, which is when the home is occupied from between 9 a.m. and 10 a.m. here. And on the other hand, you can see like a similar electricity consumption when the home is unoccupied. So we might need to use machine learning in order to identify those differences. So we can talk about the paper contribution. So the paper will introduce a new approach that leverages machine learning techniques to identify occupancy patterns using a moving window average that calculates different features such as average power, standard deviation, and range. And by using those features, we can actually improve on the accuracy and the F1 score. So we can start with the methodology. So we employed this approach. First, we get the raw aggregated power consumption data. We do some pre-processing, which like removes the illogical values. And then we do the moving moving time window, which will take like compute different attributes such as average, range, and standard deviation. And then we might need to merge the features with the labels because the datasets have they have different files for each features, like the energy and the occupancy features. And then we might need to do model training. And for the training, we're gonna use 80% of the data, and then we're gonna do the testing with 20%. And finally, we'll have the classification, which is either 0 or 1. So we can talk now about the different data sets. First one is called norm dataset. It's non-intrusive occupancy monitoring dataset. Basically, for this one, they observe the physical interaction of the occupancy with the electrical load, and they utilize multiple energy monitors, which were set up within the electrical panel of the homes. And the users actually were tracked by their mobile phone in order to identify their occupancy status. And this dataset has 3 cases. For home A, it has like summer and spring, and for home B, it's only the summer. And the collection period was around 1 week, and the resolution for taking the recordings was 1 minute. And for the other dataset, it's called the ECO dataset, which is electricity consumption and occupancy dataset. It was collected from 6 households, and each household was collected for the period of summer and the winter. However, for the 6th household, the occupancy data was not available, so we had to omit it from the analysis. And as for the detection resolution, it was 1 second, so we had to like average 60 seconds to get 1 minute in order to match with the previous data set. And these like the tables showing the cases and the collection period and the instances where the house is occupied or vacant for each case. Okay, and we had also to do some data preparation and data pre-processing for the two data sets. Like I mentioned before, they had the energy trace data or the power consumption data in a separate file than the occupancy. For the NOM data set, they had two occupants, not only one. So what we did is we've taken the maximum value for each time instance between the two occupants, and we detected that the house was occupied for that instance. And then we merged the power consumption data with the occupancy label. Also, the same is can be said for the eco data set. The power consumption data was separate from the occupancy, but for this data set, we had only one occupancy label, not two like the other data set. So we just had to merge the two together. And as for doing the pre-processing, also we included the window analysis, moving time window. And what we did is that we utilized these equations, first the average and the standard deviation and the range. And the n in the equations is the window length. So we calculate depending on that length, and we will do like a window size analysis afterward coming up. So we can move on to the results and discussion. First, we talk about the employed algorithms. We employed three machine learning algorithms. First is the KNN. And the KNN is a simple and intuitive supervised learning algorithm. It classifies data points based on their similarity to nearby neighbors. And for this analysis, we utilized 5 neighbors as the hyperparameter for the KNN. As for the decision trees, it constructs a tree-like structure with an iterative process, dividing the dataset into subsets based on the most informative feature. And for the max depth, it was not set so that the algorithm could expand until all the leaves are pure. And the final algorithm was a random forest. Random forest is like an extension of the decision tree. It has like many decision trees, and it will take like the majority vote of the different trees for the final decision. And for this algorithm, we utilized 100 runners, which is basically 100 trees. So we have now the window size analysis. For this analysis, we focused on using the KNN approach only, and we utilized it with the NOM dataset since it contains like less cases than compared to the eco dataset. And we have a visual representation of the accuracy and F1 scores compared to the moving window size. So we started with 1 and ended with 150. So you can see here, if we focus on the 60 part, the model achieved the best accuracy, and then it started declining until it got to 120, and beyond 120, the model reached a plateau, which means that the accuracy started declining or staying the same, mostly declining here. And we have here the classification results for the NOM dataset. So after implementing the moving window average with a window size of 60, which was selection for the study, we noticed a significant improvement in the performance of the model when comparing the results with utilizing only one feature, which is the raw power data, and with utilizing the 3 different features, the average and standard deviation and range. It was actually noticed mainly in terms of the accuracy. So without the moving time window, the accuracy was 88.5, and after that, actually with the decision tree, it was 98.7. So this is only for one case, and the other cases were also improved. And the major improvement was noticed with the KNN, but only for the first case, the decision tree actually improved the accuracy and the F1 score more compared to the KNN. And we have also the results for the eco data set. Since from the previous analysis, we noticed that the random forest did not actually increase the accuracy, so we tried to omit it from the analysis with the eco data set because it has like many cases. So in order to shorten the we had like a page limit, so we cannot incorporate more analysis. And we have the results with the KNN, and actually the results with the decision tree were much improved, but you can observe like the raw power data was the results with the blue, and the moving time window was with the orange. So you can see like there is a major improvement in the accuracy before and after, and also in the F1 score. But actually, the decision tree was gave better results in terms of the equi data set, and I'm gonna discuss like the differences between the before and after in the conclusion part. So in conclusion, we applied the moving window approach in the context of occupancy detection, and it has yielded significant and noteworthy results. And the analysis conducted across various cases within the norm and the equi data set demonstrated a substantial improvement in accuracy and F1 score. And the improvement was particularly evident when comparing the best performance achieved with different machine learning approaches before and after implementing the feature extraction approach. And specifically for the norm data set, there was an improvement in accuracy ranging from 4% to 23%, around 24%, and the F1 score of around 2.6 to 15%. And in the case of the equi data set, a similar trend was observed, and we found that there was an improvement in accuracy ranging from 8.3 to 25%, and F1 score improved by 4 to 17% for the decision tree. And for future work, we will focus on addressing like some of the label imbalance issues within the two data set and observe if there would be like an improvement in the accuracy and the F1 score. And that's all. Thank you for listening, and the floor is open for questions.
Thank you so much, ma'am, for the presentation. Ma'am, any questions?
Yeah. Excellent work you are doing and excellent presentation, I must say. I have
Thank you.
only one question. It's like,
Yes.
as I understand correctly, you're switching the electrical panel and you're identifying whether the home is occupied or it's vacant. Am I right?
Yes, correct.
Right. So are you also balancing the electrical panels when it is required?
For us, we
I
just
I
we
want to know
got
the
the
application
yes.
part. I mean, where will you apply this?
This is like we get the data from the power meter. It will aggregate like the power consumption for the overall house or like an apartment to be like aggregated. It will not be like for each appliance. So it's like the total consumption of the household, and we got this from like a public data sets.
All
Those
right, one
data.
small suggestion from it.
Okay.
If you are extending it for the future work, you can also work on the parallel specialization of this paper, which is called as balancing the electrical sources, which you
Okay.
can manage the power grid. So you will manage the panel powers. So which is not required, you will switch it off, and the one which is required, you will pull the resources for those who are requiring that particular sources of electricity.
Okay, I understand your point. Okay, thank you for the suggestion. Yes,
All the best.
thank you so much.
Thank you so much, ma'am. So
Thank
we'll
you.
go to the next presentation now.
Okay, I'll stop sharing. Thank you so much.
So next we have Haneen to present a paper titled Monitoring Strategies of a Company by the Model Checking Based Business Process. Are you there, ma'am? Are you there, ma'am?
I think you're not audible.
You're on mute. Please
Okay, I'm ready. Good morning.
Yeah, good
Yeah,
morning.
good morning.
Good morning. So I'm so happy to attend this conference with you from Algeria.
Okay.
I will share.
Yes, ma'am, you can start with your presentation.
Okay, thank you. Do you the screen is it's clear?
Ma'am, we can't see the screen right now.
No. And now?
Now we can see the screen. You can start.
Mr. Chairman, Mr. The Associated, the President of this session, my honorable participant, good morning. I have a pleasure to attend this conference. My name is Hanan Waar. I'm from Algeria. My domain research is the software engineering, business process, and formal paradigm. In order to well explain my paper, firstly my paper is titled "A Monitoring Strategy of a Company by the Model Chicken-Based Business Process." In order to well present my paper, I have to respect this plan. That's an introduction, the objective, the proposed solution will be explained as two main parts, an architecture and a protocol, and we apply in a case study. We present in the end a conclusion and some future research. So, business process management is a discipline for managing life cycle of business process, from the modeling phase to process enactment and improvement. Business process receive considerable attention recently by both the business administration and computer science community. Therefore, companies that adopt the methodology and business process technology get a rapid return on investment and make better use for their existing system. Moreover, business process provides a means of coordination and interaction between workers and organization in a structured way. So, however, the dynamic nature of the modern business environment means that some business process should be externalizing. It is and accept new business process from outside, or let local business process or display of a boundary of enterprise or companies. The challenge is to provide a flexibility and offer an external process support at the same time. Yet, currently, business process suffers from some limitation in optimization due to the lack of good monitoring methods, because they involve control of internal and external business process achievement, both company and business strategy in a goal achievement objective. My proposed solution is display from two parts. An architecture part of a business monitoring system. I call this business monitoring system, or BMC. Well, this is my solution. My contribution is a display for you as a structure of two layers, a strategy layers and the supervision layers in two arms. The first arms led to get an XML dashboard via monitoring strategy and using a semi-transformer to get this XML dashboard. In the right arm, we have a list of internal and external business process lists, the list of cooperative business process, and here we model a timed automata of the behavior compartment of this list of business process, internal and external. And here we proved the properties of this model using a TCTL logic temporal model to prove some properties. And finally, we get another XML file of the formal behavior of this list of business process. In the second level is a supervision level, is a set of multi-agent system. It contains main agent, the sitting agent, a coordinated agent, collector agent, and the set of mobile agent that display out boundary and to migrate to get information or measure from the collector and return and the sitting agent. This part, we have a monitoring specification of monitoring protocol. Also, the protocol of this multi-service agent is specified in this protocol. We can send a sitting and use a request to collect measure. Third, we update a sitting to launch the measurement collect and activate the code of multi-agent system to generate a set of mobile agent and send it in several locations to get measure and send send it to the collector agent that edits and reports and send the report and store it in a history database. It's a history database. And number 10 is analyze this report to alert triggers alerts if they exist. And finally, send this final report to the sender. The first sender is sitting agent. In this case study, we applied our solution in the banking called the AGB Bank in Algeria. And the strategy level, the left right, this is a day-to-day from our monitoring dashboard, the model or pattern of our XML file. And this is the new business monitoring strategy, is the BSC of our monitoring strategy. Is this I summarize this table mean the strategy of our solution of our enterprise. With the new contribution is to use it a new perspective is called the process public process. We add this new line in the classic model for 4 line. It's become 5 line. And this the result is an XML dashboard of our company. And the right part, this list, we have a list of internal business process like the human research department, accounting, customer service, credit, and withdrawal by check. And the list of the external business process is e-banking, SMS banking, e-payment, ATM, inter-account transfer. And this is the second and the main part is, and the critical part, it's the elaboration of timed automata of this of the internal of external business process using timed automata. And this is the automata that coordinates the set of of business process. And this is also the critical and the most difficult part is to write properties via TCTL language using UPAL model. And finally, we get another XML file for our formal behavior. And the supervision level, we use ACL, OCL to display the communication between agents using tools. And in general conclusion, we present a novel framework has introduction offering a monitoring architecture on 2 levels, strategy and supervision. 1, it corporate led from business strategy of enterprise. The agent paradigm is the logic language specification as a TCTL, the formal model as timed automata, and the BSC. The defined agents communicate with one another while respecting primitive of the monitoring protocol. Advantage of our solution is to increase the analysis, the suggest method add value from general agility. We prove the property of agility in this contribution. While company are able to survive in quickly change in economic ecology, exists always agility when modify independent target measurement, other specification of the BSC within involved the other. And also formal model with are more easy to update a graphical notation. It characterizes also in the process that able to independent agent to cooperate, coordinate, communicate independently. Our disadvantage is need to develop an automatic agent that generates automatically the XML file because we have used a semi-automatic on-chain. And for future research, we subject work, we plan to define other monitoring parameters such as the timed execution timed aspects of a new measure of BSC, which be strongly and analyzing. Also, for the above reason, we propose to invite an economic consultant that help for the best strategy finding and the exact internal and external business process indication. And thank you for your good listening.
Thank you
All
so
right.
much for your presentation, ma'am. Ma'am, any questions?
Yeah, thank you for the presentation, ma'am. Thank you for being with us. So this is you're proposing a framework, am I right?
Yes.
Yes. Have you heard of agile models?
I can't understand the question, please.
Okay. Is it you are designing a framework for business development?
Yes, yes.
Yes. So have you heard of agile model?
What model?
Agile model, agility, you have specified that you need an agility, right?
Yes, yes, yes.
So if a particular business needs frequent changes, then is your model is capable of doing that?
Yes, it's for future research because when using a graphical model as UPAL, we use a BSC is a semi-transformer. This is a lack of my contribution because I need to generate an automatic engine that generate XML file, and I use a semi engine.
Okay. All right. Thank you.
Thank you. Thank you again.
Thank you so much, ma'am. So we'll be moving on to the next presentation. Next up, we have Hoa to present his paper titled Optimizing Resource Allocation to Edge Devices in Edge Computing, Exploring Multi-Objectives Optimization Techniques. Are you there, sir?
Yes. Can you hear me?
Yes, sir, we can hear you. You may start with your presentation.
Okay. Uh, can you see my screen?
Yes, sir, we can see your screen. You can start.
Greetings to the esteemed judges. Initially, I would like to express my gratitude to the conference for granting me the opportunity to come here and present our paper. Um, the title of our paper is optimizing resources allocation to each device in each computing, and we have three members in the team. Okay, in our paper there are 5 main parts like this: introduction, related work, knowledge. Okay, introduce. In recent years, the rise of IoT and data-driven applications has led to its computing, providing low latency and better user experience. So allocating resources to each device is vital for success, but challenging due to conflicting objectives like minimizing communication distance and maximizing processing capacities. So in this paper, we will dive into the heart of this challenge, uh, focusing on the optimization of resource allocation for each device in computing to achieve efficiency by balancing objectives like minimizing physical distance, maximizing processing capacity, and task subset probability. In my paper, we will refer to four terms. First, a computing process data closer to the source. be resource allocation in computing. Efficient resource allocation crucial for optimal device performance. C. Multi-objective optimization techniques. In the realm of optimization, uh, reward optimization problems often involve completing objective leading to multi-objective optimization challenge in various fields. And final, that's a NHEI2 algorithm. Go to robust methods. In the domain of computing, our focus revolves around constructing an optimal function that encapsulates three fundamental objectives: distance, computing capacity, and successful processing by the edge device. Um, it's often represented by a mathematical equation like this. Mass of F1 means of F2 mass of F3. Here it represent the decision vector. F1, F2, F3 represent the computing capacity, distance, and likelihood of successful processing. uh, in a mathematical form, the multi-objective optimization problem can be stated as equation mass of mass F1 minus mass F2 and plus mass F3 and subject to constraint if any, like this. Okay. This feature simulate the workflow of algorithm the workload of SGI to algorithm. Go to our experimental resource. In an computing network with an device, each device that has unit ID, coordinates, processing speed, and success probability. And buckets sent from A to B has processing time at B by on Jamison, propagation, processing, and random delays. Jamison time. Jamison time. This resends the time taken to transmit the packet from sender to receiver and is calculated using this function Jamison time by packet size over Jamison speed. Next, propagation time is the duration it takes for the signal to travel the distance between point A and B. It is calculated using this function propagation time by distance over propagation speed. Next, that is processing time account for the time taken by the receiver to process the incoming packet. It's calculated using this equation. Processing time by packet size over processing speed minus multi probability. And final, we have a random delay. Random delay resend noise that occurs during packet transmission, introduction, unreducible delays in the processing time. And this is a total time. After that, we have a folder of total time, total time by emissions, float, propagation float, processing float delays. Okay. Is an experiment within an each computing network with about 95,000 devices. Data packets were transmitted from 5 locations. Three methods were used, that is random selection, classical, genetic, mathematics, and the NSGI2 algorithm. The result from 50,000 trials. So the NSGI2 algorithm had the best processing time, with the smallest range between minimum and maximum time. And this is data set. We can see the like longitude name of device, capacity units per second, evaluation. Before we perform trial, we need to define some variable. The first, we we initiate the generation of data packet with a size of 100 megabytes. Next, the available bandwidth for data transmission was set at 10 gigabytes per second. And final, the speed of data transmission through the wireless network were established at 344 meter per second. And after that, the outcome of our research were isolated from the dispersion of research across 50,000 trials. We can significantly see the difference between three methods. And um, when we random selection, the second of random selection is very large, but the density is very low. When we use NHA2 algorithm, the second is very low, but the higher of density is very high. Okay. Conclusion. The ASGA2 algorithm optimize processing resource allocation to each device effectively by solving complex optimization problem involving distance, processing capacity, and subset probability. It outperforms other algorithms, especially in scenarios with high processing requests in e-computing.
We sincerely
Thank you. That is on my research.
Thank you so much for your presentation, sir. Ma'am, any questions?
Yeah, I have only one question. Can you please show me the fitness function for this multi-objective optimization? Have you defined any function, fitness function?
Wait. My Wi-Fi is very sorry. Can you repeat the question?
Yeah, I just want to know what is the function, fitness function for multi-objective optimization.
Okay. Uh, uh,
All right, thank you.
Thank you so much, sir, for your presentation. So we'll be moving on to the next presentation. Next up, we have Margu to present his paper titled Silent Subcarrier Based Interference Rejection Combining for Mobile Black Space Cognitive Radios. Are you there, sir?
Yes, I am.
You may start with the presentation, sir.
Can you see the screen?
Yes, sir, your screen is showing. You can start.
Okay. I'm a professor emeritus at the University of Technology, Finland. And my co-authors completed their PhD a couple of years ago, but they wanted to continue a bit further their earlier studies. They are both now in industry. And starting with outline, so I start by briefly introducing the principle of black space cognitive radio, and then introducing multi-antenna techniques and interference rejection combining based on multiple antennas. That is a key element in this black space cognitive radio for interference cancellation. And then we talk about spatial covariance estimation. That is the way for this interference cancellation, considering the black space cognitive radio.
Sir, you are not audible. Anchita?
Yeah. So actually, I guess sir's mic is unmuted. Sir, can you hear us? Oh. Sir, can you hear us?
Sorry.
Yeah. Sir, can you hear us?
I guess there is some
I guess
problem with
there is some
internet
issue.
connectivity. Yeah, his
Yeah.
internet might be having issues. It's very slow, right?
Yeah, so can we start with the next presentation till then?
Yeah, you may. You should.
Yeah, okay.
We'll just ask the next presenter if they are ready.
Yeah, I'll do. So next up, we have Inda. Next up, we have Inda to present her paper titled Understanding the Impacts of Internet Addiction on Impulse Buying, Exploring Task Orientation and Self-Efficacy. Are you there, ma'am?
Yeah.
Okay. You may start with the presentation.
Thank you. Let me share it. I can share my screen.
You'll be able to share the screen, ma'am.
Okay. Can you see my sharing screen now?
Yes, ma'am, we can. You may start.
Okay. Good morning, everyone. I'm Indah Fatmawati, and greeting from Indonesia and from Universitas Muhammadiyah Yogyakarta, Indonesia. And I have one co-author, Farah Anindya Fernanda. I'd like to present our study entitled Understanding the Impact of Internet Addiction on Impulse Buying, Exploring Task Orientation and Self-Efficacy. So this is behavioral research regarding the use of internet. And this is the outline of our presentation, starting from introduction, research objective, theoretical background, conceptual definition, hypothesis, research model, method, results, instrument testing, goodness of fit test, hypothesis testing, mediation test, and discussion, conclusion, limitation, and list of reference. In introduction, we tell about the information and communication technology that particularly the internet has become a critical driver on socioeconomic development in many countries, which positively influencing economic growth, productivity, and employment. And due to the widespread growth of e-commerce, online impulse purchase have become common among shoppers. The convenience of online shopping removes the limitation often found in brick and click or mortar stores, leading to higher chance of impulsive buying. Impulse buying is a phenomenon that arises when a person feels a sudden sense of urgency that they cannot resist. Consumer may impulse purchase with little thought when they see an appealing product or bargain. And internet addiction is one of the factors that cause impulsive buying behavior. Internet addiction is a temporary phenomenon that allows individuals to be associated with the initial novelty of internet and will gradually fade with increasing personal familiarity with another individual. And the other factors that influence internet addiction is self-efficacy. Self-efficacy is a person's belief about his chance of completing particular tasks, and consumers who have self-efficacy can control and put aside their emotion, impulses, behavior regarding impulsive purchases. We consider also, the research objective. Our research objective is intended to investigate the influence of task orientation and self-efficacy on internet addiction, which influence impulse buying. We simplified the previous framework with purposive sample technique, which different from the previous one, which used convenience sampling techniques. And setting of this research is Shopee online shopping application in Indonesia. And for the theoretical background, we use the theory of stimulus organism response, which explain about how particular stimuli can influence a particular organism, which in turn would give a response based on the stimuli that they got, that they receive. And this is the conceptual definition in our study. First is task orientation, which refer to the degree to which a person establishes objective and accomplish tasks. And then self-efficacy, which refer to the individual beliefs about his ability to do a job successfully. And the next is internet addiction. Internet addiction is characterized by excessive preoccupation, urge, or uncontrolled behavior regarding computer use and internet access that leads to disorder. The next is impulsive buying. Impulsive buying happens when individuals suddenly desire to purchase with a product without carefully thinking about why they need it, whether they need it, or the reason behind it. And this is the hypothesis in our study. We developed 7 hypotheses. And this is the research model that we propose in our study. In our study, we propose that task orientation and self-efficacy influence internet addiction, and in turn, which influence impulse buying. The method that we use quantitative study with explanatory research design. We conducted an online survey using Google Form involving 161 respondents. And the study object is Shopee, an online shopping application in Indonesia. The sample was selected using purposive sampling with several criteria. Shopee users, at least 17 years old, have made an online impulse purchase at Shopee in the last 3 months. And the conceptualization and measurement of our research variable refer to the previous research. The task orientation is measured in 5 indicators: self-efficacy is represented in 5 indicators. 5 indicators measures internet addiction, and 8 indicators measure impulse buying. The total 23 items used in this study were measured in a point Likert scale from 1 strongly disagree until 5 strongly agree. In the results, the respondents of our study are Shopee users who have purchased in the last 3 months, and of 161 respondents, 77% were women, and the rest were men, and 88.8% were between 20 until 25 years old, and the majority had a high school education. The rest were college graduate. Finally, respondent with monthly expenditure greater than 1 million in rupiah, Indonesian rupiah. For the instrument testing, we conducted instrument testing to determine whether the research instrument had met the valid and reliable criteria. An item is considered valid and significant if the loading factors value equals or exceed of 0.5. Our results indicated that 23 statement items tested for validity have a loading factors greater than 0.7 and thus considered valid. A reliability test showed the consistency of a measuring instrument. The authors used construct reliability, which greater than 0.7, to assess the construct reliability. The results showed that all 4 construct have construct reliability value greater than 0.8. Thus, we conclude that all of the construct are reliable. For the goodness of fit test, we conducted the goodness of fit test, and this is the results of goodness of fit test. Based on several indicators that we use, only 2 which consider marginal and the rest were considered fit. It means that the proposed model that we propose in our study can be used in our further step of our research. And for hypothesis testing, we use AMOS-SAM, and this is the results of our hypothesis testing. The first 5 direct hypotheses showed a significant and positive results based on the criteria is based on the probability value is 0.05 and the critical ratio is 1.96, and the data is considered significant if the probability value is 0.05. The basis for determining the positive hypothesis is the absence of a negative sign in the estimated value. For the mediation test, to test our mediating hypothesis, we compare between the direct relationship and indirect relationship. And based on the direct and indirect comparison, we conclude that the mediation effect happens. Conclusion, based on the obtained results and previous discussion, we reached several conclusions. The significant effect of the first hypothesis indicated that task orientation is a predictor for internet addiction, and internet addiction is a predictor for impulse buying. Thus, although there is support for the task orientation and impulse buying relationship, we rejected hypothesis 6 about the mediation effect. And self-efficacy positively influence internet addiction, and based on the significant finding of internet addiction and impulse buying relationship, a significant finding of self-efficacy and impulse buying relationship, and the greater indirect effect of the self-efficacy on impulse buying compared to direct effect. We conclude that hypothesis 7 is supported. It means internet addiction mediated the relationship between self-efficacy and impulse buying. Besides the limited predictors in our research model and sample size limitation, the proportion of respondent age was dominated by teenage respondent, which may influence the result. We consider this as our limitation. Thus, we recommend that the future studies consider a more comprehensive research model to get a better explanation of the impulse buying phenomenon. We also recommend a bigger sample size with a better respondent background variety to improve the generalizability of our present finding. That's all for our presentation, and thank you for watching.
Thank you so much for your presentation, ma'am. Ma'am, do you have any questions?
Yes, thank you, ma'am. And it's a very interesting topic, the impulsiveness for the purchasing on the internet. So I understand it's a study project. Have you implemented it yet?
This is already conducted. The research already conducted. Sorry, what do you mean by implement?
You have collected the data, or have you
Yes.
done any experimentation on it?
Yeah, we already conduct the data collection, and when we reach about 50 respondents, we conduct instrument testing, and then we continue until the final step. But unfortunately, only 161 respondents that we collect due to the time limitation.
All right, ma'am. Thank you.
Welcome.
Thank you so much, ma'am. So we'll move
Okay.
on to the next presentation. That is, we have the next presenter, Marku, to present his paper titled Silent Subcarrier Base Interference Rejection Combining for Mobile Black Space Cognitive Radios. Are you there, sir? Are you there, sir? Okay.
We can move on to the next, Anshita.
So, I would like to sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for each one of you. We, on the behalf of the whole team, thank you for your support during this 9th version of the conference and all the previous 8 versions for the same. We will be happy to see you in the 10th version in 2025 as well.
Anshita,
Yeah.
just one sec. If you check your chat box, there is one ma'am who is saying she's left with the presentation. Could you please check?
Yeah.
Lorna is left with the presentation.
No, she's not in the session. I'll talk to her, ma'am.
Or different room, maybe.
Um, Excuse me, ma'am.
You can leave the message on the chat box. I think she is there online.
Yeah, I did. Thank you.
Hi.
Yeah, ma'am, your presentation is in the next slot. It's in the 6D. We're currently running 5D session. Your session is 6D.
So, Anshita,
Uh,
are we done with
Use
today's presentation of this
is
slot?
this on the same link?
Yeah, it is on the same
Ma'am,
link. It is on the same link, but on the later time. You can check the schedule.
on the later time. Oh, I see. I'm sorry. I thought I was late a while ago, so
It's okay.
I joined this link. So I would be presenting, but later in the next
Yeah, next session.
batch.
Yeah.
Thank you so much. Now I understood. Thank you.
Anshita, are we done with the presentations of this slot?
Yes, ma'am. I'll be concluding the session.
All right. So we also need to take a group photograph before we close the session.
Yes, ma'am. Yes.
All right. Thank you.
So I would like to thank each one of you for being there and for supporting us. And we will be happy to see you in the 10th version as well. All the presenters would be getting their digital certificates within the 2 working days. Further, all the papers have been already forwarded to the sponsor. The publication will be live within the 6 months, so kindly cooperate with the team of ICICT 2024. I would also like to thank our session chair, Dr. Preeti Parwekar, for chairing this session. And ma'am, this is a token of appreciation and love on the behalf of the team of ICICT 2024 and Global Knowledge Research Foundation. Would
Thank
you like
you.
to share a closing remark with us?
Yeah, thank you, Anshita. And I would like to congratulate all the authors for presenting their research work. We got to know the various research dimensions where you all are working, and wish you all the best for your career. You may carry on the further future work as you have proposed for your research. Thank you, everyone.
Okay, so I would request everyone to please open their cameras for a quick snapshot.
Hello, this is Marco. I have the connection again. Can you hear me?
Okay.
I lost the network
I
for
think
some
sir
reason.
is back. If you are ready, sir, we can have your
Yeah,
presentation.
ma'am. Sir, if your net is working properly, we can have your presentation.
Okay, let's try again.
Okay. You may please start with the presentation, sir.
Yes, I'll try. Oh.
Sir, are you able to share the screen?
Yeah, I'm trying, but I'm not
Okay. Okay, so you
having
may,
some difficulty.
yeah, you may start with the presentation. sir.
Yes. So can you see the screen now?
Yeah, so we can see the Zoom one screen. Before that we were able to see your presentation, so we can see your screen.
Okay, now this. Okay, can you see it now?
Yeah, sir. Yeah, you can.
Okay. Sorry for all the hassle. So the title is Silent Subcarrier-Based Interference Rejection Combining for Mobile Black Space Cognitive Radio. And yes, the overview. Let's go to the next slide. So we talk about cognitive radio and idealism, spectrum sharing or reuse. And the reason is because in wireless communications, there's a demand for more capacity and the spectrum is quite crowded. And cognitive radio is one way to enhance the usage of spectrum. So let's talk about spectrum sharing or spectrum reuse. And the picture here is my students' idea about sharing resources. And so various legacy communication services like terrestrial TV broadcasting are not using the spectrum so efficiently. So many channels are not used all the time, and there are free resources that cognitive radio tries to use. And the most common cognitive radio could be called white space cognitive radio. So it's using the time frequency gaps in the transmissions of legacy services that are called primary users for secondary communication by the cognitive radios. And the other approach that we are using here is called black space cognitive radio. And the idea here is to transmit the cognitive radio signal with so small power level that it doesn't disturb the primary user communication. And the key element here is interference rejection combining by using multiple antenna techniques. So cognitive radios are intelligent, meaning that they analyze and understand the radio frequency environment and use the knowledge for reusing the resources. And the key point is that cognitive radio should not cause harmful interference for the primary users. And about multi-antenna techniques, MIMO techniques, they can be used for improving the radio link spectrum efficiency and reliability. And there are many multi-antenna techniques, but we focus here on beamforming on the receiver side. So the lower figure here shows the basic form of beamforming, maximum ratio combining, where the idea is to maximize the signal to noise ratio from the target transmitter. And this is done by linearly combining the different antenna signals by using complex weights that result in coherent reception. And this is used in cases where there's no significant interference from other directions. Then the upper figure is about interference rejection combining, where the idea is to maximize the signal to noise ratio of the target signal, but also suppressing the interference signals coming from the directions where there's interference. And here we use different weights for the antennas. And in backspace cognitive radio, we want to maximize the signal coming from the target CR transmitter and suppress all the interference from other directions. And generally with N receiver antennas, we can suppress N-1 interference. And so really we use backspace cognitive radio in this way, and having the cognitive radio transmission in so small power level that it doesn't harm the primary user. And it's assumed that, okay, we are using multi-carrier modulation called OFDM, which transmit the signals in hundreds or thousands of narrowband subcarrier signals. And this is widely used in wireless communications these days. And we assume that primary signal and cognitive radio are synchronized. And the synchronization is fairly straightforward, since the primary user signal is received at high power level. And then this in OFDM, this IRC processing can be done independently for all subcarriers. And then for the cancellation, you need to obtain the sample, the covariance of the different antenna signals. And this, there are two ways to reach that. One is based on the estimating the channel of the primary user, and then we can obtain this covariance sample with covariance matrix by the shown formula. And the other ways that we are considering is the so-called sample covariance approach, where we just observe the signal vectors from coming different antennas in a number of different time instances. And this is the sample covariance that we are using. And then we are using sample covariance here because it's allowing also to suppress the primary user interference and also interference from possible other cognitive radios that are operating in the same region. And we have considered two ways for obtaining this sample covariance, because the cognitive radio transmission is discontinued while estimating this sample covariance. And earlier we used time domain caps, during which the cognitive radio is not transmitting in between the data transmission blocks of the cognitive radio. And the other approach is to use silent subcarriers. So here we use every second or so subcarrier is silent, not transmitting cognitive radio data. And these subcarrier signals are used for estimating the sample covariance. And then we interpolate our subcarriers to get a good estimate for the sample covariance for the data subcarriers. This is showing the scenario and system model. And here we use OFDM parameters following this 4G LTE system, and assume time and frequency synchronization between cognitive radio and primary user, and consider many pedestrian mobilities, and use covariance interpolation in case of silent gaps in the time direction, and over subcarriers in case of silent subcarriers. And channel estimation for the cognitive radio is done after removing the interference from the antenna signals. And then these weights that are used for antenna combining are obtained by multiplying the channel vector in the target direction by the inverse of the sample covariance matrix. And here we see simulation results, comparison, and we use signal to interference ratios of -10 dB or -20 dB. So in black space cognitive radio, we have a very small signal to interference ratios, like in this 20 dB case. The interference signals is 100 times stronger than the target cognitive radio signal. We use two mobilities, 0 and 20 kilometers per hour, and we have equal overhead due to the silent intervals in both schemes when comparing the schemes. And we see from the figure that we have the lowest curve here is the ideal reference based on perfect knowledge of the sample covariance. And with zero mobility, even with this high signal, very small signal to interference ratio, we almost reach the ideal performance. And with 10 and 20 dB, -10 and -20 dB signal to interference ratios, then the performance is somewhat reduced. But we observe that the new method using silent subcarriers is better than the earlier method, silent gaps, in some degree. Okay, that concludes my presentation. So thank you for your attention.
Thank you so much, sir, for your presentation. Ma'am, do you have any questions?
No, thank you so much, sir.
Okay.
We can-
Okay, thank
I-
you for this opportunity.
Yeah, so I would request everyone to please open their cameras for a quick snapshot. So can you please stop sharing? Yeah, thank you.
Yes.
So we'll be taking a quick snapshot. Yeah. Thank you everyone for joining and for your valuable presence.
Thank you.
Forward to see you again. Okay, bye. Bye, ma'am. Thank you.
Bye.
Bye-bye. Thank you.
Thank you.